Hi everybody, welcome to another video in linear algebra, section 2.7, applications to computer graphics. There are many applications in computer graphics. The textbook used this example that I said we have an object characterized by those control points. So let's say the n is characterized by this point. If we want to transform that into something else, all we need to write is the coordinate of those points, and then we multiply by a matrix, and then we can transform that into something. Because we use this a lot in computer games or animation. We just have the point control, those control points, and then we're moving those control points, make the object move in certain ways. Right. Actually, I prefer to use another example in the digital images. Right. So one of the basic type of image is the RGB, which stands for red, green, and blue. Red, green, and blue color model is a different color model in red, green, and blue. So all the line blend together and give us some particular color. By the way, that definition I just copied from Wikipedia. Here's the link. This also from that. So now, different color we can represent using this case what we call is called hex, or called the hex triplet, or the triplet of hexadecimal number. So for example, the color white is 6F. This is a hex triplet. So we have three components: red, green, and blue. So we have that. So what FF means? So this is the hexadecimal system. So let's say the hexadecimal. Just like decimal we have from 0 to 9, hexadecimal we have 0 to 9. And then we have A to F. Where the values of A is 10, B is 11, and F is 15. Of course, all the way from 10 to 15 for A to F. So now, when we write the number, let's see if we write 23 base 10. What we do is 23 base 10 is going to be equal to 2 times 10 plus 3. That is in base 10. Now, if we write something in hexadecimal, for example, if I write 23 in hexadecimal base 16, it's going to be 2 times 16 plus 3. Right? So in that case, what is? So for example, for Y is FF for red, FF for green, and FF for blue. So what is FF equal to in the hexadecimal? So FF in base 16 is going to be F times 16 plus F. And F is equal to 15 in the decimal system. So we have 15 times 16 plus 15. It's 255. So does that number sound familiar? Right. Now, if you consider the values from 0 to 255, we can write that in the hexadecimal system as 00 to FF. in hexadecimal. And so from 0 to 255 is 256. The significance of 256 is that it is equal to 2 to the 8. And in computer, 1 bit can take the values of 0 and 1. So a bit can be 0 or 1. So they have 2 values, and 1 byte is equal to 8 bits, meaning 1 byte is 8 bits. So we have that we'll have 2 to the 8, which is 256 different values. Right. So in this case, this is we take 3 bytes for 1 values. Anyway, so for red, in this case white, we have FF, green also FF, and blue is FF, meaning that we have 255 white. For white is maximum intensity, 255 is the maximum light for red, maximum light for green, and maximum light for blue. So all 3 different color, red, green, and blue, the intensity of that to 100% of each color will produce the color white. So 100% of red, 100% of green, and 100% of blue all together give us white. In terms of black, which is doesn't have or dark, doesn't have any light, meaning that they have 0 for all 3 the color, red, green, and blue. So we have 0, 0 for red, 0, 0 for green, and 0, 0 for blue. So now you will see that for red, we have the first maximum 100% red, and then actually this is green because this is the light, so it is so different color on the computer than when I bring out on paper. But we have maximum intensity green, and then the blue, of course, is going to be maximum on the blue. So red, green, and blue. Of course, when we combine green and blue, we have this color, and when we combine red and blue, we have this color. Right. Now I have an example here. Suppose now just make something very simple. Let's say we have red. Let's say we have an image of 2 pixel by 2 pixels. So I draw each pixel different. So that is the red. And then green. Since I do have 4 different colors, I'm just going to use it. We'll see the blue. Red, green, and blue. And then the last one, I black ink. Right. So if I have an image like that, 2 by 2 pixel, in terms of matrix, I can split that into 3 different matrices of color red will be maximum intensity. So if I could use FF, or I use 255 if I want the decimal values. And then the color green doesn't have any red in it, so on the red, that's what I have. For the green, I will have 0, red doesn't have any green in it, green have maximum amount of green, and black doesn't have any light in it. And then green, and then blue. We have 255 here. Right. So to store that image, to store that image of 2 by 2 pixel in that color, I can store using 3 matrix, one for red, one for green, and one for blue. When I put all of that together, we have represent that matrix. Right. Usually, when I do the research in image analysis, that's the first thing we do. We take the image, decompose that into different colors, red, green, and blue, and then we work on each one and then maybe combine them in some certain ways. Right, so it's just a pixel, and each pixel take a color, and the color would be a blend of red, green, and blue, and the color is given by this called the hex triplet, the triplet of hexadecimal number. Right. So this is the project that I did a few years ago. I took the original image, which is nice picture, and of course, as mentioned before, each pixel is a color. And what I did was I turned into this picture, and you said that it looked worse. But if we zoom in very close to the picture, and you see I replace a black pixel by black rose, the ground picture by a pine cone, or whatever that color is, with different flowers. And there's some certain color that I could not find a flower or whatever color represented by this shade yet, so I couldn't finish that project. What I did instead was this one. So I cheat. Okay, so this is a very high resolution picture, so I cheated. I just used one picture of a rose, but I changed the color of the rose into different shade and corresponding to the shade of the pixel. So I have a black rose, green rose, and so on. So all of them are just a picture of a rose, different colors put together instead of a pixel, and we have the image. Right. So this is one of the very fundamental thing we could do with the image. I thought that is interesting, but that's all I want to cover this section. As always, thank you for watching, and see you in another video in linear